Controlling Your Architecture with Philippe Kruchten.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem and architectural methods have to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. They are hiring both architects and .NET engineers who'd like to have a path to become an architect. You can go to clearmeasure.com/careers for that. Our guest today on the show is Philippe Kruchten, and he has over 35 years of software development experience and is now retired. Most of that experience is in large technical systems, telecommunication, defense, aerospace, software tools, and then between 10 and 20 years as an educator and researcher in a major Canadian engineering school. Philippe, welcome to the show. How are you, sir?
Thank you. I'm pretty good.
My pleasure. Now, I do know that on the show before, we've had some other guests that reference what is now a very old model that you put out in the 90s, the 4+1 architecture diagrams and model for evolutionary architecture. But you've been writing and publishing and teaching on software-intensive systems for a long time. For those listeners who might just be getting familiar with your work and haven't read it before, could you give a quick overview of some of the highlights that you've enjoyed over your software career?
Well, I started as a mechanical engineer, but in the 70s, there was a big demand for software, and this looked pretty intriguing. So I jumped into software pretty rapidly. I worked in a large European telecommunication company called Alcatel, developing telephone switches, which at the time were the really big pieces of software. And this is where a lot of the early software engineering development methods were invented by companies like Siemens, Philips, Alcatel, AT&T, and so on. And then I joined an interesting company, a little startup in the Silicon Valley called Rational Software. And I became a technical consultant in software architecture. And this was my opportunity to travel the world because I'm interested mostly in large software systems, and they don't all come to your own neighborhood. So you have to go where they're developed. So I worked in Germany, the UK. We moved to Sweden for a while, then in the Silicon Valley, and I ended up in Vancouver. I had to stop moving around because by the time I reached Vancouver, I had 3 kids at school. So,
oh, wow.
But I continued to travel a lot. Half of my team was in Stockholm, the other half was in Vancouver. So after a while, being a consultant is useful, but you collect a lot of experience from seeing all these catastrophic projects that you try to help recover. We try to capture that into a software development method called the Rational Unified Process. And in that process, I was the person looking at software architecture. That's what you were referring to. And I was doing that with people who are pretty well known in our industry, about my age, Grady Booch, for example, or Jim, and people like that who developed the UML, that funny notation.
Awesome. Well, with so much formative history in our industry, and certainly, the Rational Unified Process and others kind of predated the Agile movement coming in 2001, which kind of led into the DevOps movement, which started being talked about in 2010. But over that time, what have your observations been regarding architecture? Has a lot changed, or have some things stayed the same from your observation?
I think we've made some progress. We understand the role of architecture a little bit better. We are still hindered by the fact that architecture, it's hard to grasp. It's hidden out there in the software. It's not visible at the surface. And software architects have a hard time convincing their surroundings that more attention needs to be dedicated to architecture, to getting the right architecture, to fixing it, evolving it. People are way more interested by looking at more features at the surface of the system rather than, oh yeah, well, what you have in the guts of the system, it doesn't matter that much. That's not what we're selling with the sales people tell you. So we've gone, I think, a long way in making architecture a first-class citizen in a few organizations. And I still run into companies where the architecture just happens and nobody is actually aware of it and can explain it. It's just there. But they're rarer and rarer. Before we met, I was just reading some news that software architect is one of the most demanded position right now in the US. So
that's not surprising.
On IT work, there's probably a lot of people who are needed in restaurants, kitchen, and places like that. But in the IT work, it looks like software architect is now something very valuable.
I'd love a hypothesis around that, because I've mentioned on the show some of these statistics that Stack Overflow has shared on developer trends, and that over the last 7 to 8 years, the number of programmers coming into the industry is of sufficient size that there are now twice as many people programming code as there were 7, 8 years ago. And so if we haven't kept up at some ratio of software architects in other roles, then there could be some imbalances there. What for the listeners and all those, half of the listeners out there that are maybe earlier in their career just doing the programming, how do you define what the heck architecture even is, and how is it different from coding?
Well, architecture, for me, it's the set of design decisions that you have to make, usually early in the life of a system, that will actually condition a lot of things in terms of structure and behavior of the system, and also satisfy a lot of the relatively hard to satisfy entities, like performance. Well, it doesn't end up in utility, but it's evolvability, testability, maintainability. And so it's not programming, although the architecture will end up being code somewhere. The act of developing a software architecture, it's more about decision making and understanding the intricate network of decisions and how they relate to each other and how they depend to each other. There's a lot of programmers, but most of those programmers are going to work in an environment where there is an initial de facto architecture. There's a lot of architecture that are just replicated. And people say, oh, yeah, architecture, that's not very important. Yes, because somebody did the job for you, 2 years ago, 10 years ago. And you're just replicating the same architectural pattern. So not every software developer needs to be a software architect, but they need to understand what is the architecture of the system I'm working on. So I don't do design decisions that actually invalidate or clashes with the architectural decisions that were made last year or 10 years ago.
I think probably last year, you were one of the authors on another white paper called "Building and Evaluating a Theory of Architectural Technical Debt in Software-Intensive Systems." So you've been working on this in architecture for a huge chunk of your career. What are the highlights that you think are the most impactful that you put in that paper that are still valid in 2021?
Well, if you're referring to the paper about architectural technical debt, well,
yes,
that's just it shows up in a lot of systems that are suddenly becoming very hard to evolve. And if people don't have an architectural mindset, they don't realize that it's because of the architecture. They may be things in the architecture that are not understood. So this is basically technical debt at the documentation level. There is no documentation. The architecture is there, hidden in the code, but nobody knows about it. And the people who've developed it, they're long gone. They've retired. They've moved to some greener pastures. And so there may be architectural debt because of just ignorance of the architecture, but there's also technical debt because what was the right decision 10 years ago or 2 years ago or 6 months ago is no longer the right decision now because the environment has evolved, the ecosystem has evolved, the customers have evolved, the requirements have moved on. So you end up being in a position of architectural technical debt, not because you made the wrong decisions 10 years ago, but because those decisions are not the right one in the current circumstances. Then there is architectural debt because what you did 10 years ago was just plain stupid, and now you're paying for it. So that's what that paper, if I had to summarize a 40-page paper in a few sentences, would say. You have today architectural technical debt in your software because either you don't understand the architecture because it's not documented properly, or because your environment has evolved, both the technical environment, but also the the commercial environment, or because, yes, there was some stuff that was suboptimal that you did or they did 10 years ago.
So the first part, let's talk about the first part first. You mentioned the team broadly doesn't understand the architecture. It's just there, but we don't have a clear picture of what it is. It's not documented somewhere. Today, in 2022, what type of architectural documentation do you favor? We've heard some people talk about architecture decision records. Some favor different layers of diagrams. How should people think about how to document the architecture?
Well, it depends. Who are you documenting the architecture for? And this is where the concept of view and viewpoints arise. The architecture of a software-intensive system, especially if it's a large distributed system over the world, it's that tangled board of thing. And if you try to look at it and try to represent it, which people tried very hard to do in the 70s, using PowerPoint and all kind of colorful arrows and boxes and triangles and things like that. If you try to represent all the reality of the architecture on one single blueprint, you're lost. There's about just the author who can actually make sense of the diagram. So you need to sort of say, let me look at the architecture from different viewpoints. Am I looking at it from the person doing operation of the system? Or am I looking at it from the software developer that we just put on board last week? Or are we looking at it from, the person doing some tuning of the load balancing of the system? So you need to take one viewpoint and then document the architecture from that viewpoint. And this is where the 4+1 view model that you were referring to comes from. It's taking 5 different viewpoints and developing different perspective on the system from those 5 different viewpoints. But it's not a decomposition of the system. It's the same system. The system is one. It's just seen from a different angle. I got the idea from my sister, who was an architect, a building architect, not a software architect. Architects, they use different blueprints. They use floor plans and they use elevation, and they have specialized blueprint for the people doing the plumbing, and they have specialized blueprint from people doing the electrical stuff and people doing the elevators and things like that. You have specialized blueprint for different perspective, different viewpoint. But those blueprints need to be very carefully coordinated. On the floor plan, I see the holes where the piping is going. I see the holes where the elevators are going. So they are coordinated. Well, it's exactly the same concept with a representation of the architecture. Now, architectural blueprints, you can, if you have a very simple system that runs on a single processor, you don't need a deployment view. You don't need to show different software repositories and DLLs and executable and apps running on different processors. But if you have a very widely distributed system running on 100 nodes, then that view becomes very important, especially for people in ops, the ops part of DevOps. Mm-hmm. If you just want to make sense and have a roadmap of the 2 million lines of code that sits on that machine, you need a different view. You need a developer view or code view that shows what are the packages that are imported, the ones that are developed locally, what their dependency between them. If I do an update of Azure, what is the size of the damage, what needs to be retested. So that's a very different viewpoint. If you're doing tuning of the load of the system, understanding where the processes are, the threads, and the processes or the tasks, whatever you call them, where do they run, what's the code for them, and it's relatively important. I remember seeing that system where people were lost. There were hundreds and hundreds of processes, and they had no clue what those processes were doing there and why some of them were dying. Well, that's another viewpoint. So I could multiply things. Decisions were not part of my original paper, but around 2004, we started to realize that design decisions are a viewpoint in themselves. We've decided that this will be in the system. We've decided that this will not be in the system. We've decided that, what are the design decisions that actually can then be linked to various elements of the architecture, the documentation, if you're using views and diagrams and things like that. So around the mid-2000s, there's a lot of people who finally understood that design decisions were really the key element there to manipulate, and that the other views depended on them. Yes, because we've decided to use Azure, then this code appears on the code view, then these processors appear on the running system, then we have to distribute things in this way. I know nothing about Azure, so I'm just using that placeholder.
Sure.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
So, in short, regardless of the format, each key audience that needs to do something needs a view specific to them. Like you mentioned, the plumber, the electrician, so
yeah.
and ops and whatnot. So multiple views of the same system. And then you also mentioned decisions. Are those just as simple as Word documents or text documents with we decided this and why? Just text?
For design decisions, it would be nice to have a little template and just document it as text.
Okay, so just prose, a few paragraphs.
Yeah. Well, the decision, the reason, the rationale for the decision, we've chosen this because, and maybe the rationale includes we've looked at this alternative and we discarded it and we looked at this alternative. So which alternatives have been looked at? Maybe dependencies. We can only do this because we have already decided this. And the two are now linked. If we change this other design decision, then this one is moot.
Mm-hmm. Okay.
So that text is usually relatively enough. If you want to represent things like a deployment system, then having diagrams helps. And I can pitch you for things from the UML. If you have a logical view, use a class diagram or a package diagram. If you have a deployment view, use a deployment diagram. But you can use any other representation as long as you specify what the boxes and the arrows mean.
Sure.
Diagrams are useful to communicate from architect to another audience. So if you're giving a presentation to a new audience, like newcomers in the company, it's probably better to start with a few simple diagrams representing some of the views that I've mentioned, depending on who's sitting in the room there, than giving them 200 pages of text, which is a little bit boring. I've done it. Sometimes you need both. You need a few diagrams and the text that explains what the diagram actually really means. But if you have a logical diagram, basically you will find there the major classes that you will find in your domain. If you have an air traffic control system, you will find aircraft, airlines, beacons, airways, airports, and things like that. That's what a logical view would look like. So if you're speaking to people who are going to do new requirements development, business analysts and people like that, that's the view they're interested in. But if you're speaking about people deploying it on a new air traffic control system, they're more interested in knowing where the DLLs are and the executables and the data repositories. So a totally different set of views would be useful. The sum of all those views is your architecture documentation.
Okay.
It doesn't need to be big. Actually, people say, we have a very big system, so the architecture documentation is probably about 500 pages. That's way too big. You should be able to explain the architecture for a large system, 120 pages.
Yeah.
If you go beyond that, you're already into the details. And the details, you can find them in the code. There's no need to have the documentation paraphrase the code.
Right. Well, you've been a consultant as well as an educator and researcher. If someone is, whether it's a consultant or whether it's just a new person on the team coming into a team where they have a rather large code base and any kind of diagrams that might be there are woefully out of date where no one really uses them, is there a particular method or approach to understanding or harvesting the actual architecture?
Yeah, you can use some tools to explore the structure. You can use tools to actually extract some of the structure of the code. Some of the views are more difficult to extract just from the code, and you may have to speak to the people who are actually doing the work. Where each executable resides, it's hidden in some script somewhere that are usually relatively cryptic and maintained only by a few people in ops. So you can reverse engineer the architecture. This is something that I've had to do many times when as a consultant. Well, the first thing, I need to understand your architecture. Oh, well, we don't know where it is exactly. Well, let's roll up our sleeve and let's look at the code structure. So you would start by the code because the code is the real truth in the end. So that's what you can trust. And out of that, you can extract some diagrams about the code view, and then at a higher level of abstraction about the logical view. And then you can start digging and asking questions about some of the other views. Where do things reside? What runs on which processors? Where are the data repositories? Those are more going around the offices and asking a pointy question to people who are aware of the architecture. So I've done a lot of things using both approaches. A systematic approach using some of the tools that at the time Rational Software was selling to do some extracting some architectural information from the system and then interviewing key people to complete that and get an embryo of the various views. And doing things iteratively and presenting those views to the people who are knowledgeable in the system. Does that represent really the system? And then you yes, sort of, but you're missing. Okay, what am I missing? And then you would, this is what it was supposed to be, but actually we haven't really done that. So you can cut this off. Oh, you mean there's some dead code? Oh, yeah, this code is never run. That kind of thing. So,
okay. With existing teams, systems have been around a long time. It's common to realize that a new architectural element may be needed, or there needs to be some sort of shift. Towards the end of the your white paper on 4+1 architecture blueprints, you talk a little bit about evolving architecture. But what is your current view? And you're in a situation where you do have the diagrams, and now somebody or whether it's a named architect or a lot of teams just have a group of developers and they just together have to do the architecture. How should they go about deciding and communicating big shifts like that?
Well, they have to do something which is still black magic in software development. They have to do an estimation of the amount of effort they have to throw at it. And to do that, you'll have to look at dependencies. You have to understand relatively well the dependencies. So there's the new thing that you need to put there or to replace. What will be the impact? And you need more than oh yeah, easy, I've done that before, 2 days. It may be much more than that, because we rarely understand completely all the ramification of some of the changes that we do. So doing an impact analysis, doing a what if we were to change that, and look at what Git will tell you, or ClearCase, or whatever is your favorite tool there, in terms of impact on the code. But you need also to look at other impact on the deployment, impact on the testing, impact on the documentation, and the documentation in all these funny languages that are not English, and so on. So there's usually a wide impact in the sales material. You need to retrain some of the things that the salespeople used to say, because once we do that change, this will be wrong. So doing an impact analysis, and then maybe doing some little prototyping, using some iteration or sprint to actually try things out to make sure that we haven't missed something big. Oh, wow. Although there was no direct dependencies between those two things, they are related indirectly via some data repository. So there was no dependency code to code, but there were some other hidden dependencies that we had misunderstood or whatever. So if it's a big architectural change, I would do it carefully by doing some very systematic impact analysis and not just relying on the dependencies in the code, and then doing some little prototyping. Let's try to change that on a dead branch of the development tree to sort of see what impact we may have missed or misunderstood.
Well, as we close up the interview, you've had a very long career focused on not just software and being a part of teams building software directly, but on thinking about the whole industry, how the industry does software. Do you have any issues that still remain completely unsolved, that some of your peers or somebody else needs to pick up the mantle and help the industry solve some problems that still linger?
Yeah, I was hinting at it a few minutes ago. I think we're still very, very at the very beginning in terms of estimating the effort that we have to dedicate to a certain development. The perfect development model is the waterfall. I know it's a bit of an anathema that I'm going to say. Well, if you know exactly what's going ahead, then you can do things without having to iterate. Why do we iterate? It's to palliate our deficiencies in terms of being unable to anticipate a design, to anticipate the effort and things like that. So we iterate, which is a good thing. I'm not against iterating. But if you look at other engineering disciplines like civil engineering, Eiffel didn't have a few iterations to build the Eiffel Tower. He had only one shot at it, so he'd better have all the design done early on. Well, in software, we are not there yet. We don't know very well how to estimate the amount of effort that we'll have to throw at a certain problem in order to get it solved by software. So that's one thing that over 40 years, I don't think we've made a lot of progress. Speak to Steve McConnell about it. He wrote a whole book on the topic.
Right.
Otherwise, I think we are closer. In 35 years ago, when I started in software, we were looking at 45 years ago. Gee. Yeah, years pass by and you don't realize.
Right.
We were redoing and rebuilding the same software again and again. Now we have large amount of components, ready-made software that we can use to assemble relatively rapidly, relatively sophisticated system. So this has changed a lot. Now, a very good software developer is one that understands all these packages in a certain ecosystem out there, and which version to use, which one not to use, who's developing that, which group is splitting this branch of open source software into two branches, and which of the two we're going to follow. And so that's a skill that well, there was not much software to reuse except some mathematical libraries when I started in software. So that has changed a lot. We also understand a little bit better the dynamics in teams. That was the influence of the agile movement, how people, interact and communicate, and, daily stand-up meeting and retrospective and all that kind of thing. That was a very good development appearing around 2000. That didn't exist much or only in a few companies before in 1970s and 80s. We've also understood how to do things iteratively a little bit better. I've done iterative development since I was at Alcatel, but it took a long, long time for our industry to get to that. Some people thought the agile movement was just totally crazy when they started. And we are now 20 years later, and now it's the standard way of doing things. 2-week iteration.
Right.
Is, by the way, not necessarily 2 weeks. You have large teams that can iterate very well at 1 month into iteration. So sometimes it's a little bit artificial, but another day.
Well, Philippe, thank you so much for coming on the show. This was fascinating for me, and I'm sure it was for the listeners as well. And so thank you for doing that. And we'll make sure everything that we mentioned, we'll make sure to include links to it in the show notes, the various white papers and techniques that we mentioned. So thank you so much for coming on.
Thank you for having me.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.